I'm going to start with a question. What happens to good ideas that don't fit neatly into existing systems of funding? Well, at ETH, we have researchers doing remarkable work. AI, robotics, advanced materials, biotechnology, much of it with genuine potential for space applications. But the path from a promising concept to something that actually flies is long and fraught with uncertainty. Traditional funding works well for rigorous, methodical science. But it wasn't built for speed. It wasn't built for the kind of rapid iteration that the commercial space sector increasingly needs. Which is why we created a different approach. As you already heard, my name is Marco, and together with my co-founders, we've built the Pi Innovation Hub, named after the mathematical constant pi. The hub is our answer to the question. What we do is straightforward. We identify promising research from across ETH's departments, help transform them into focused demonstrations, rapidly prototype, and build the partnerships needed to get it tested in space. Think of us as a fast lane for concepts that are ready to move, but don't fit neatly into existing systems of funding. The key enablers are autonomy and discretionary funding. We can say yes quickly, we can pivot if something isn't working, and we can pursue unexpected opportunities when they arise. So let me share a few of our projects. This first idea began with an unusual connection. One ETH department had developed AI algorithms for early bark beetle detection and tree health monitoring. Like they needed a way to get hyperspectral cameras over Swiss forests regularly. Another department had built this hydrogen-powered drone, which can fly up to 12 hours autonomously. We made an introduction and they're now building that aerial infrastructure, a practical way to collect data now because hyperspectral cameras are still years away. The next project is ArboSat-1, a composite-wood satellite that could solve a growing environmental problem. 100,000 plus satellites are planned over the next decade. The problem is that when they re-enter, their aluminum structures release harmful chemicals that might affect the ozone layer. ArboSat-1, developed together with Swiss Wood Solutions and ETH spin-off, is using a structural-grade wood composite that matches aluminum strengths but burns up cleanly on re-entry. We're now working with our Space Master students to validate this technology in orbit. ArboSat-1 launches with our partner Space Locker to the International Space Station later this year. It comprises a small module, 2 by 10 by 10 centimeters, with embedded sensors for continuous monitoring. 6 months of exposure, then back to Earth for analysis. From concept to flight ready in 10 months. Alpine is a GPS receiver for spacecraft. The project comes from ETH's work on low-cost GPS technology. Now, traditional GPS systems for spacecraft can cost up to €100,000 and weigh up to 2 kilograms. Our payload weighs just 63 grams and costs €1,500. It enables dual-frequency measurement of the Earth's ionosphere. This is useful for space weather monitoring, tsunami detection over oceans, and for precise spacecraft positioning. We have built multiple flight-ready units and are actively looking for rideshare partners to validate the technology in orbit. Now, Alpine doesn't just reduce costs. It enables field expansion. It enables research groups and universities that are priced out to participate. This is our most ambitious project. Bingo takes a different approach to exploration. Instead of a single expensive instrument like a rover, we deploy networks of many small, simple sensors that can work collectively. Each node is smaller than a golf ball. They use ultra-wideband radio for positioning, time-of-flight sensors, cameras, radars, mesh networking. They communicate peer-to-peer and can collectively map environments where GPS doesn't work and traditional instruments might fail. The long-term goal is mapping lunar lava tubes, underground structures on the moon that might harbor water ice and could shelter future habitats. First, we're testing this on Earth in Swiss caves, alpine glaciers, and volcanic formations. Each deployment will teach us something about how these networks behave and provides new data about our own planet. So I'd like to talk a moment about how our funding structure works, because it's essential to how we operate. We have received moderate seed funding from the university, enough to operate through 2027. That gives us an opportunity to show that our model works. We also have philanthropic partners who want to support the function itself. Flexible funding that let us move fast and take risks on ideas before they are safe bets. The products we fund then graduates to conventional funding channels like ESA programs, products, industry partnerships. We are an accelerator for the initial phase, not a replacement for serious institutional investment. We are dealing with a specific niche, projects too early for traditional funding and too promising to let wait. This is the gap where we can operate. Now, this kind of work doesn't happen in isolation. It requires collaboration. So, I like to make an invitation. Maybe one of these projects connects to something you're working on. Maybe you know researchers or companies we should meet. Maybe you want to support this work philanthropically, or know someone else, a foundation or a family office, that might. If so, then we'd love to hear from you. Become a part of what we're building, a pipeline for faster innovation. And answer that question. What happens to good ideas that don't fit neatly into existing systems of funding? Now, we called it pi because the number captures something about this work. Unending, surprising, and always revealing new possibilities. What we're building is an early mission formulation pipeline, a way to take promising Swiss research and move it towards space faster than traditional pathways allow. Now, whether it stays a small experiment or becomes an integral part of a uniquely Swiss space program, that depends on its success and whether others see the value in what we're doing. What I can say is that the projects are real, the results are measurable, and Switzerland has always been known for precision and reliability. The Pi Innovation Hub is adding speed to that equation. So if this interests you, I welcome the conversation. Please find me afterwards or reach out. Thank you very much for your attention. Thank you.